All right. Good morning. First real day. Here we go. Okay. I stole this. Anything I steal will be just out of the textbook, which you can just get the PDF, so you can have it. But I stole this. Obviously, it's a great introduction. We're starting here in chapter 1, which Mina has called Hello Data, which is very cute. Because in programming, you often do a Hello World document where you kind of introduce some key things. And so here we're doing Hello Data. Very, very cute. So we'll start. Obviously, we kind of have an understanding of collecting data and things like that, but usually we don't have a very good understanding of what statistics is. So statistics, that's the part I wanted to highlight here. So statistics is the study of how to best collect data, which is a field of its own within stats. Okay. Analyze data, which can be anything really, and then how to draw conclusions from data. Okay. And we're calling this a data science course, but that's really just kind of you want to be with the cool kids, but really what we're doing is statistics, right? So one day within my working career, statisticians woke up one day and said, we're data scientists. And they were just doing the same thing, but it was just more sellable. It sounded cooler. And we're just doing statistics. I would say for me, and there's a lot of debate, obviously, about this. Are you a statistician or are you a data scientist? For me, I would say the distinction is you're doing the same things, but a data scientist has to focus on kind of communicating the results with reports and things like that, and might not go as deep into the analysis, okay? Which is kind of more on the side that we're on, but we have to learn some statistics to be able to get there. And so first thing we're going to do in this chapter is just learn some terminology about, how can we talk about data? And so when I say variable, you say what? No, variable, what? But when I say variable, you need to know what I mean, right? And when I say numerical variable, you need to know what that means, right? And when I say categorical variable, you need to know what that means, right? And so all these terms, I don't know, probably easiest to just memorize them to start, right? No one likes memorizing, or maybe you do. Flex your brain muscles, right? The more you memorize, the more you're able to memorize, right? And so for me, a lot of this starts with memorization until it clicks, okay? So we collect data, we analyze data, and we report data or information and conclusions from data, right? That's a whole whack of things that we do, right? And so let's think about data that you might collect. You would probably store it in a spreadsheet, right? Kind of bare minimum, a spreadsheet. Then you can move up to a database where you can kind of connect different spreadsheets by some link, right? You can kind of take it as hard as you want, right? But we're going to start with spreadsheets. We're only going to work with a spreadsheet type of situation. Okay? So what does a spreadsheet typically look like? So don't close your eyes, you'll fall asleep. But imagine a spreadsheet. What does it look like? Probably something, and I'm going to do Hey, why is my pen all jumpy? Or glitchy, I should say. Here. Something like this. We don't usually have this line here, but we will for our purposes, right? And so you can kind of imagine this line, but usually we have some sort of observation. Okay, maybe it needs to connect or something. This isn't gonna work, is it? Let me try getting closer. So observation 1, 2, 3, 4, all the way up to, I can't believe this is going to be my first thing that I'm going to say, all the way up to a lowercase n. N, actually, I introduced observation first, but the first thing I'm going to talk about is n is the sample size. Okay. Number of observations that you have is n. Okay. You use a lowercase n for the sample size. Okay. Side note, a capital N, what can I do? What color can I do? Maybe I'll do purple, just so you have kind of the big brother version. So a capital N is going to be for the population size. Okay. And so population size. So it's not going to be in our spreadsheet unless you're lucky enough to have information on the whole population. But then you don't need statistics, because then you can just figure out whatever it is you want to learn about from your population, and you can just know it with certainty, right? Versus statistics, which is we take a sample and we're trying to use that sample to learn about what the population might reasonably look like, right? And so, oh yeah, I see some pictures happening. I'll post these notes, of course, on Moodle, so you'll have them. Don't worry, but yeah, take pictures if you need to. Okay, so this relationship where we have notation for the sample and notation for the population, that's going to haunt us all term, right? Because we're going to have a sample mean, average, better, right? They're the same, but we don't know that yet, maybe. Right, we're going to have a sample average, but we're trying to use that to learn about the population average, right? And so we need notation for each of these, and they're going to be different, right? They have to be different, otherwise they're hard to tell apart, impossible even. And so, right, so that's something that we really need to keep a handle on, is where did this information come from, right? And so that's why notation is going to be so picky. Okay. Then what? Then I have my columns, right? In my spreadsheet, I have columns, as many columns as I have collected information on, right? And so I'm just going to get right to it and call them variables. Okay? Variable 1, variable 2, variable 3, keeps going. You can have as many variables as you want. Okay? So the columns here, should have given myself more room. The columns are variables. Oops. Maybe, I don't know. I don't know how to fix my pen, but that's okay. Notice that the observation number is not a variable, okay? It's just an identifier. Okay. And so here, what color can I use? Maybe lighter green. Observation is not a variable, just an ID. Why do we call them variables? Because the information that we get from each observation, right, is going to vary, right? We expect each of these things, right, each of these pieces of information from observation 1 to potentially be different from observation 2, right? Let's start talking about maybe something that we can all imagine, a grade spreadsheet, right? And so you see your grades, right? But of course, on my end, I have all your grades in a spreadsheet, right? So what's that going to look like? If I make it kind of just sort by student number, right? I'd have your student number or your name or whatever, some sort of identifier, right? For whose grades do I have here? Whose information do I have here, right? And so might look something like this. So for example, a grade spreadsheet. Let's say, now it's better. I have a student ID, student number, whatever you want to call it, right? Student 1, 2, 3, all the way up to N students. Let's say, I think last time I checked, how many were we? We were, I think we were full 30. Maybe 28. I might be getting my classes mixed up. It doesn't matter. So I have 30 students, right? So my sample size is 30. And now I get information like, what do I get? I get information like, what's your email? Student 1 has an email, and it's pretty obvious that student 2 should have a different email, right? Student 3 should have a different email from the previous 2, right? And so the emails vary from student to student, right? Kind of a basic case. I get information on your program. Right? Again, each of you, right? A lot of you are in the wet program, but even in the wet program, there's 2 different streams. Right? And so, right? So then I have information on which stream you're in, right? And then, right? So even that can vary from student to student. Students are allowed to be in the same program, right? We just don't know for sure what program they're in until we have that information given to us, right? So it'll still vary. Okay? What about, let's say I get information, I don't. I wish it'd be kind of fun. But let's say I got information on what year you're in, right? What year of school you're in, right? First year, second year, third year. I can't keep the wet. There's like a work term somewhere in there that I think you just came back from. I don't know. And so, and then you're here for another half a year or something. I don't know. It's so confusing to me. But you're in first year, you're in second year, third year, fourth year, fifth year, victory lap. Whoop, whoop. Which is what I did. It's normal, guys. It is. And so what else could I have? I might have your test 1 grade. Uh-oh, getting real here. I might have your test 2 grade. Right. All these grades vary from student to student, right? And there's no room for an assignment grade. That's okay, right? Let's do a final exam grade. An attendance grade. Oh, I did look into. No, you're right. You're right. Attendance. There, much better. No final exam. No, I did look into it. The lowest I can go without having it be approved by the dean's office and stuff is 35%. So that's better, right? So we can do that. Anyways, that's like a side project. We're talking about variables here. So we know what an email looks like, right? And so there are kind of 2 main types of variables, okay? And so if let's just draw them out, and I think you can let your intuition guide you for most of the way, okay? And so a variable is either categorical or numerical. There are many, many, many more sublevels, but for us, this is all I really care about. For the categorical, I'm going to take it 1 step deeper just so that you're able to do the questions in the textbook, but it's not something that I personally care about. It's really just, sorry, this says numerical. Let me zoom in. There. Still not that great, but anyways. So this is all I'll really care about, right? Can you distinguish between a categorical variable and a numerical variable? So if you just kind of, like I said, let your intuition guide you, just categories, right? Can you put things into categories, or is it going to be a number, right? And so then email, right? This variable should probably be categorical, right? How about program? Put you into different categories, right? And so still categorical for program. The reason this is so important is because how you analyze things, right? Your first decision thing, or point, I should say, in your decision tree is it a categorical variable or is it a numerical variable? We're going to have techniques for both, right? But you have to choose the right one. And so, right, we can talk about email's pretty boring, right? Because we would just have 1 email per student and there's really nothing to analyze there, right? And so that's pretty boring. But how about program? What would you do for program, right? So we've got maybe, I can't remember what the wet streams are, but we've got wet 1, wet 2, let's call them. And let's say you're in the sciences and maybe, I don't know, nursing, just to spice things up, right? And so, right, then we have 4 categories and every student fits into one of those 4 categories, right? The analysis is kind of boring, right? What would you report? You could report 30% of students were nursing students, right? 50% of students were in the wet program, right? And then break those down, right? And so we're really just kind of converting counts into percentages is usually what we do, right? And so for categorical variables, we usually just report counts or percentages. Our brains do really well with percentages, right? And so often that's how we communicate information. So if you want to report, 80% of the class is in the wet program, right? That's a categorical variable that you're reporting on. Now for numerical data, we usually report the average, right? There are other things that we can measure, but I like to use the argument that I kind of flip what we report back onto arguing whether it's a numerical variable or a categorical variable. And so my argument is it's numerical because it makes sense to talk about the average, right? And so we report the average, right? And so for the numerical variable, I usually ask, does it make sense to talk about the average, right? And we can calculate differences and addition, subtraction, right? Because they're supposed to be just numbers, right? So does it make sense to talk about the average? Right. It's kind of usually how I frame it. So of course, you're going to have to I give you some data and you have to tell me what type of variable it is and why, right? And so this is the argument that you're going to use. It's numerical because it makes sense to talk about the average, right? I missed a prime opportunity, I'm realizing here. How about I squeeze it in here? Let's say I have your phone number. Oh, that's sneaky. It's a number, but does it make sense to talk about the average? Not really, right? Or not at all, actually, right? You don't want to know about the average area code or anything like that. That doesn't mean anything, right? And so there are kind of some traps like that, but that's when it makes it easier if you just kind of step back and say, does it make sense to talk about the average, right? Yes or no, okay? And so here, the phone number would still be categorical. What's difficult about stats is it's not like math in the way that there's always a right and a wrong answer, right? There are opportunities to convince me, right? And so if you use solid arguments, right? I'm thinking about the year you're in, right? Just kind of, okay, what would you argue? And you don't have to tell me because I can be swayed either way, right? Does it make sense to report the average year that students in this class are in? Yeah, sure, right? Or if you told me, nope, I'm going to treat it as categorical because it doesn't make sense to me to talk about the average, right? I'm okay with that, as long as you use the right reason, right? And so it can't just be no because I don't want to. That doesn't do it for me, right? But you have to convince me with the right argument. Okay. So this one, I would say categorical or numerical. Tricky, right? We want it to be yes or no, right? And that's what makes stats kind of difficult, right? It also depends on how you want to report your information later, right? And so we don't have that knowledge yet, and we don't have those skills yet. But later, right, if you want to break things into groups, right, by the year that people are in, then you should say it's categorical, right? Because that's what you do with categories, right? So you can split things into groups. Okay. But if you want to talk about the average year and you want to report the average year, then you would say it's numerical. Okay. Test 1 should probably be the same as test 2. They're both grades, right? They're numerical grades, right? And so I'll highlight that I would I'm still waffling on what I would call this one. I'll keep it vague. But all these should behave the same way, right? They're all grades, and so they're numerical, right? There's some number. You could convert the number to letter grades, right? But the problem is you can't convert a letter grade to a back to a number, right? And so we have that tool if we need it, where we can convert a numerical variable into a categorical variable, but you can't go back, right? Unless you saved your original data, which you should. But if you don't have that, right, then you can't go backwards, right? But think about income categories, right? Everyone's done a survey at some point, right? And I hope if you haven't done a survey, go find a survey. Right, they'll ask for your income categories. They don't ask you for your income because that would be weird. And so they have to stick with categories, right? So they have to treat it as a categorical variable, right? Even though it is a number, and they could potentially find the average if they had the actual numbers. Okay. I think I mentioned I used to work at a market research firm, and so we did a lot of kind of government contracts, and they collect surveys, and I'd analyze the data and report back. And so every morning I got into work and I would check how many completions I had. So now whenever I get a survey, I'm like, oh, okay, but how many Pizza Hut surveys can you do, right? Still waiting for my free pizza. I don't know how I'm gonna get it. Anyways, they know they've got me. So, okay, good. I will make a note here about my little rant, okay? We can always convert numerical to categorical, right? Income categories, for example. But we can't convert categorical to numerical. Okay. Like I said, I want to take the categorical just one step further. We can take the numerical one step further too, but I want to use maybe a different color here. So I'll start off with the same kind of tree, categorical, oops, versus numerical. Categorical variable is either ordinal or nominal. Okay. I've never taught a psychology stats, but I have tutored a psychology stats. So I know in psychology, because they do a lot of surveys and a lot of them collect categorical information, they go like 7 layers deeper. So there are lots and lots and lots of layers, right? Even if it's nominal, there's different types of nominals. Even if it's ordinal, there's different types of ordinals, right? So you can go deeper, but I'm calling it here at the very first level, but you should be aware of these terms so that you can do the textbook problems. Okay. Now, what's an ordinal variable? An ordinal variable has some natural order. Okay. So some natural order. Right. Year of school, for example. If you were reporting on year of school, first year, second year, third year, fourth year, would you report it third year, second year, first year, fourth year? No, that's weird, right? And so there's this natural ordering, right? And so year of school, for example, oops, spelled school wrong, the irony. So if there's some natural ordering, right, then you call it ordinal. Okay? And it has that clue. I love etymology. Do you guys know etymology? It's like the study of words, kind of breaking down words and why words are the way they are. And so if you just kind of spend some time getting to know the words, they'll give you clues. Right? And so it kind of a stretch, but nominal, I underline the no because there's no order, right? And so there's no natural ordering, right? If we do car color, for example, it's a categorical variable, right? I ask you, okay, if you have a car, what color is your car? We'd have all these categories, right? But there's no natural ordering. You can impose order, right? Alphabetical, for example, right? But there's no natural ordering. And so no natural order. For example, car color. More common, I would say, to have nominal categorical variables. But if you do have an ordinal variable, you want to take that into account. So reporting income categories, for example, right? There's some natural order there, right? You've made these categories and they kind of jump, and they follow each other. And so then when you're reporting these things, you should probably keep that same order, right? It doesn't make sense otherwise. Let me scoot this. Scoot this over here. So we do have subcategories for the numerical variable as well. Okay. So a numerical variable is either continuous or discrete. The difference between these two can be very, very subtle, okay? And for me, difficult at times, okay? But just so you can get the right answer when you do the textbook problems, they say that any count is going to be discrete, right? And so if I ask you how old you are, right, you're not going to tell me your some number of days and hours and seconds. You can, it exists, right? You are some age on a continuous scale, right? You could go very, very deep, but we don't, right? And so for that reason, it's just a count and we call it discrete. Okay? Whereas a continuous variable can take on any number, right? If we're talking about your grades, for example, right? I could report it to 3 decimal places if I wanted to, right? And it would still have some numbers there. Okay, and so here, discrete, we're gonna say is a count, right? So if it's a count, age, I don't know, what else? How many times do you order Pizza Hut in a month? Probably 4. I think I'm on the higher end. It's very convenient, and I love it. Whereas a continuous variable is going to be a measurement on a continuous scale. I know, rude, using its own terminology against itself. So things like grades, speed, height, lots of things are continuous. Yeah. The reason I only need you to know these guys, right? Let me highlight that. Is it the color or my writing or both? Okay.
Now I can't see my paper.
I know.
Just let your eyes again. Actually, no.
Study by moonlight. Oh.
So if you saw like a series of data and it was all like whole numbers, integers, would it be like an indicator that it's a set of like discrete variables, or like, because that could also be a set of continuous values? You just, how would you be able to distinguish between the two?
So that's kind of the problem. We don't really need to distinguish between the two, and so that's why I only focus on just the categorical and the numerical. I would say if all of them are integers, if all your observations and you set out only collecting integers, then you could say they're discrete, right? But yeah, kind of, it's pretty tricky. Hey, but now my yellow highlight isn't very good, is it? Hopefully that's better. Okay. We will only need these. Right? And the reason for that is, especially like I just said, for the numerical data, right, is it doesn't matter if it's continuous or discrete, our analysis stays the same, right? So for our purposes, it really doesn't matter distinguishing between discrete and continuous, but it's good to be aware that these terms exist. Yeah. Same thing for categorical data, right? Ordinal, nominal, the analysis stays the same, right? You do a categorical data analysis, right? And so for our purposes, it doesn't matter, but like I said, it's good to be aware that these things exist. I see I made a mess here. There. Okay. Time to muddy the waters a little bit. Because depending on what field you're in, a categorical variable can also be called or qualitative variable. It has some quality, right? I prefer to use categorical because it really leads us down the right path, right? But if you have learned qualitative, right, it has some quality and that makes sense to you, then use that. I'll know what you mean, right? But I'll be using categorical and numerical. Okay? And for the numerical variable, it can be a quantitative variable, right? Some quantity, right? And so definitely in my field, we call it quantitative analysis and qualitative analysis, right? Especially in kind of job postings and things like that. But if you see kind of quantitative data analysis, then you know you're going to be focusing on the numerical, right? And if you see qualitative data analysis, then you know it's a focus on the categorical, right? And they tend to hire different people because it takes time to learn all these skills, right? So, okay. I promised terms. Should I keep them coming? Yeah. So we can analyze just one variable, right? Is it categorical? Is it numerical? We can, if we have a numerical variable, we can talk about the average, right? That'll only get us so far. Often we're interested in the relationship between two variables, right? And so we are often interested in the relationship between two variables. I'm going to focus on two numerical variables to start, and then we can talk about two categorical variables. Okay. So two numerical variables. For example, maybe test 1 and test 2. Oh, or even better, test 1 and attendance. Oops. Ugh. That says attendance.
That's 5% of our grade.
Well, you'll still have a grade in attendance, so it's not weighted very heavily. But if I asked you to look at these two things and tell me if there's a relationship between these two things, right? So I give you a grade column of test 1 and I give you a grade column of attendance. I don't give you the student numbers or anything, right? What would you do? Kind of think about, okay, we're problem solving here, right? And maybe, maybe you would make a scatter plot. Maybe. There's probably other things. You could go from student to student and compare the two, right? And say, but is there a relationship? That gets very tedious, right? And so often what we do is we visualize a relationship with a scatter plot. We visualize this relationship with a scatter plot. Now, a scatter plot, probably seen them before, right? Maybe not called them scatter plots, but let's I'll be biased. I'll make big dots here. Let's say my data looks like this. Those dots are supposed to be the same, but it's from my pressure, I guess. Right? If I have 30 students, how many dots should I have? Should have 30 dots, right? And so I didn't count, but it's just an example, right? So each dot is going to be a coordinate from each student, right? And so each student has, I'll try not to use green anymore. Let's see. What do I put on the y-axis? On the y, let's refresh here. This is your y-axis and this is your x-axis. Let's start there. Okay. On your y-axis is always going to be the thing that you're most interested in. Okay. And so maybe in this case, and in a lot of cases, it doesn't really matter. It's just how you want to frame your problem, right? And how you want to frame your analysis. In this case, maybe I want to know, hey, does the test one grade, does it depend on attendance, right? Is it affected by the attendance grade? Okay. And so I'm going to put test one on the y-axis. Okay. And I'm going to put attendance on the x-axis. Okay. And I should those are for sure. The light blue is just test one attendance specific. Okay. If I gave you this visualization, which after we've collected data is usually the next stop, right? If you're scrolling through your spreadsheet to try to figure out what's going on, that's going to be really tedious, and you might have, 2 million lines of information, and you don't want to do that anymore, obviously. And because you're not going to be able to extract anything. So then the next step is to visualize your data, right? We're not there yet. We have to learn terms about data. Then we're going to talk about how we collect data properly. And then we'll talk about how do we visualize data properly. But here's a common visualization that we use and summarization technique. Okay, so a scatter plot looks like this. And so I have what I'm going to call, or what we call, a response variable. Making test one your response variable. So the response variable is the variable we are most interested in and maybe I'll say slash, because very quickly we're going to move towards wanting to predict test one grades from the attendance grade, right? I only give you the attendance grade, then what do you predict the test one grade will be, right? And so the variable we're most interested in slash the variable we want to predict just like before, depending on what field you're in, right? You might have called this your dependent variable. But I stick to response. But again, if you like dependent and spoiler alert, independent variables instead, that's fine. I'll know what you mean, but I'm going to use response variable and what? The explanatory variable. I use explanatory because it goes on the x-axis, but it's also just more helpful. So the explanatory variable or the independent variable. What's the explanatory variable? Clue in the name, right? We use this variable to help explain changes in the response variable, which is the thing I'm interested in, right? And so the explanatory variable the variable we hope will explain changes in the response variable. Let me see. I feel like we did an XY axis, but just in case the X and the Y, it's kind of hard to remember again, then tell the story. I had a student one time who couldn't keep them straight, the X and the Y axis, which is kind of a funny thing to think about. Once you have it under control, it's like, well, yeah, of course. But she just couldn't keep them straight. And so she said, okay, well, I imagine, you know, the Y axis is a tree, and then there's some little guy down here, and he's like, no, because the tree's falling on him. I guess it's going down. Pretty cute. Pretty elaborate. Right? But now you'll remember which one is the x-axis and which one is the other one. You only need to remember when it's binary, right? When there's only two things, you only need to remember one, and then the other one just follows, right? So pretty cute, but yeah. Anyways. I wish I could draw it as well as she did, but I think you get it. And so the x-axis, that's where you put your explanatory variable. But really the thing we're interested in goes on the y-axis. Right? If I'm interested in predicting test 1 grades, right, I could have used test 2 grades or attendance. I could have potentially used what year you're in, right? What do you think that relationship might look like, right? The year you're in is kind of tricky. Or maybe I should say, maybe I pretend. Let's pretend I have this information. Test 1 and your age. you think age is a good predictor of your test one grades? I don't think so. I think, you know, your age, you know, as you get older, you might be more serious and you might, you know, kind of have your study skills down. But generally, what would I as a teacher would expect to see? What kind of relationship? I would expect to see maybe something like this. What's the difference between this relationship and this relationship? Besides my dots being way more sloppy. Here, I can draw a line and I can say, hey, I can kind of summarize this behavior with this upward sloping line, right? Whereas here, if I had to summarize this behavior, right, or model this behavior, right, which is what we will be doing, okay, it would probably look something like this. Right? So if I see something like this, where it's just kind of a straight line is the best way I can summarize it, that means that there's no relationship between age and your test one grades, right? Because I could plug in, I don't know, how old are you when you start? 18? I don't know. I actually don't know. Right, I could plug in 18, 17, I don't know. Child prodigy here. Right, and I would get the same prediction for test one as I would for, I don't know, let's go here so I don't have to pick it up for age 35. Right? And so when I get the same prediction, right, regardless of what the age is, right? And so let's get this here. Predicted test one grade is at that line. Right? I'm kind of getting ahead of myself, but not really, right? We're gonna review this as it comes up, but the line is your predicted test one grade, okay? Whereas here, this line is also your predicted test one grade. If I plug in a low attendance, I get a low test one grade prediction. If I plug in a high attendance, I get a high test one prediction. I know I'm cooking the books, but it's also probably true. I never take attendance. Sounds like I might have to. No. We'll do something more fun than attendance. So here, right, the attendance grade that I plug in will explain changes in the test one grade, right? Whereas here, the age I plug in, it doesn't affect my predicted test one grade. They're always the same, right? And so here, we see age is, let's do this, does not explain changes in test one grades. We'll talk about the slope and things like that, but then I'm really getting ahead of myself. And so, right, really what we're saying is that there is no relationship or no association is often what we we say? Okay. No relationship or no association between age and test one grades. Whereas here, I would say there is a relationship between attendance and test one grades, right? We see a relationship between attendance and test one grades. That's sloppy, I shouldn't use the plus. How we can describe this relationship. This, if I asked you, okay, this line that I drew, can you think of a better way of modeling this or summarizing this relationship? Pardon? Oh, yeah. Now you're way ahead. I was thinking more, no, a straight line seems to do the trick. You're way ahead. And so we're going to be talking about linear relationships. And in this course, we really only talk about linear models because there's a trick. Even if you have a non-linear model, something that looks like, right? You might have something that looks like this. Oh, a strong relationship, but it's non-linear. Right, this is a non-linear relationship. But I'm trying to think back and I feel like we did some non-linear relationships where we just, what did we do? We transform one of the variables until we have a straight line, right? And so all those skills that we learn, they all go back to a straight line. So that's why it's the most important one to learn, right? And then you can kind of manipulate your data. Taking the log of a variable, for example, is a really common thing that we do. You guys have seen your log graphs and things like that. And so that's a really common transformation that we do. And it forces a linear relationship, right? And then we can apply these linear model techniques. Okay? And so that's why in all intro stats, we start with a linear model because you can always kind of work towards a linear model, right? Manipulate it until you have one. Okay, yeah.
How diagonal a line should be for us to say that there's a relationship between two values? If the slope is like at 0.0, 0.01, so it's basically 0, then it means that there's a relationship.
So now again, we're kind of diving deeper. There are tools to determine if it's a significant relationship, right? But we're gonna need some skills before we can get there. But yeah, so it is gonna go back to the slope, right? The value of the slope here, and if the slope is close to 0, we expect it to be not significantly different from 0, right? Whereas if it's, the slope is 2 or something like that, then it's usually significantly different from 0, right? Here, a straight line across like this, that's a slope of 0, right? And so here, I'll put the slope is 0. Or rather, not significantly different from 0, right? Essentially 0. So we'll have tools for that, but we have to wait. Okay. Good. And is that the right time? That's another thing I should check. Yeah, pretty good. Okay. So in this course, we will focus on linear models. Right? On linear models. That's cool, right? Line of best fit. We just call them models now, but that's what they are, right? Modeling sounds cool, right? And so we're going to focus on linear models, right? Because often we can transform our data to turn it into a linear model, to turn it into a linear relationship, I should say. To describe a relationship, there are three things that we need to talk about. Okay. So to describe a relationship, remember that's our job here, is not just producing these scatter plots, but also to communicate, okay, what did you find, right? And so to describe a relationship between two numerical variables, we need to talk about three things. First, we need to talk about whether it's linear or non-linear, right? That's a good breakdown. For us, it'll always be linear, but it's good to be aware. Linear versus non-linear. If you can kind of push towards a linear relationship, then there are ways to confirm that it is in fact a linear relationship. But like I said, the tools that we have are a lot easier if you have a linear relationship, right? Otherwise you have to force it. You know? But so that's kind of something you want to push for, right? Is that you say, okay, I think this is probably a linear relationship, right? That's going to happen a lot in this course, where there are kind of some things that you want to be arguing for, even if you look at it and you say, oh, well, I think I can see some non-linearity here, broad strokes, right? Just kind of squint, and can you be convinced that a linear model would fit, right? That a straight line would do the job, right? So is it linear or is it non-linear, right? It would have to be very clear like this to say it's non-linear, right? This is not a line, it's a curve. Then we can talk about the strength of the relationship, right? And so the strength of the relationship, we'll just stick to weak or strong. And as we get more comfortable, we can start kind of moderately weak, moderately strong. But if you just want to stick to weak and strong, that's totally fine by me. Weak versus strong. If you can see any sort of pattern, it's strong, right? Which kind of goes against we want all the points to be super, super tight, right? To say it's strong. But as soon as you see a pattern, right, you can call it a strong relationship. Okay. But that's where those modifiers come in, right? moderately strong, right? But for now, we're just gonna have two distinctions. Okay, and so here, if you can see any pattern, it is strong. That also takes some getting used to, right? So this description is going to be very broad strokes. Okay. Would you ever want to report on a weak relationship, right? Maybe in the sense that we found no relationship between age and your test one grades, but that's as far as you would go, right? That would just be one blurb in your report. You wouldn't want to kind of visualize it and analyze it because there's nothing there. Okay. Let's see here. We don't analyze weak relationships. Should put that on a t-shirt. I think it works. And then we want to talk about the direction of this relationship. Direction of the relationship is either positive or negative. A positive relationship is if X is increasing, Y is increasing as well. But also, right, if you add a little arrow on the end, it's going up, 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 right? So that's a positive relationship. Whenever I do examples, I always default to a positive relationship, sunny side of the street and all. But also I think it's easier to draw. Whereas a negative relationship looks like what? A negative relationship, you put a little arrow on the end, is going down, right? As your X's are increasing, right? So as your X's are increasing, then your Y's are decreasing. I can't think of a grade type relationship. Usually grades kind of increase together, right? Yeah, I can't think of one off the top of my head. That doesn't matter. Looks like this. Okay. So we need to talk about all these three things. Okay. I have to avoid the light green, but maybe a dark green. There. Oh, I guess I should check it. Yeah, that's better, right? Than the light green, I think. We need to discuss these three things to describe a relationship between two variables. Two numerical variables. Yeah. I am simplifying a little bit, okay? Because in our previous examples, right, so I'll say in this course, especially in this chapter, there's a lot of, in this course, we're only gonna do this, right? Obviously, we can expand our horizons, but We can't do a whole field in one course. And so in this course, our response variable will always be numerical. The response variable will be numerical. We're gonna have some number on the y-axis, right? Do you want to know what it would be if it, yeah, why not? Even though I heard a distinct no. If the response is categorical, we use logistic regression. But that's not in this course, but just so you know, it exists, right? The explanatory variable, we said, okay, in this very kind of introductory situation, it's going to be numerical, but we could have categorical variables on the x-axis. And so our response variable, I'll say, will usually be numerical, but could be categorical. So it's allowed to be categorical? Question. Thanks. Thank you, thank you. Because I had finished writing, I guess I should have written it in red. And a self-punishing red. But I forgot. Yeah. So it could be categorical, it's allowed to be categorical. Right. Just makes your data look a little bit weird. Right? What would it look like? Or your scatter plot rather would look maybe like this. You have your test 1 grade. And then let's say you have program 1. Oops, let's do this. 1, 2, 3. Let's throw a 4th one on there. Right, we said whatever program you're in, that's a categorical variable. That's the question. Just musing. That is in this course. Oh yeah. Well, I'm just showing what it would look like if it was categorical, because we haven't seen one before, because it can be categorical. Yeah, it's just the green that's not, that's like a future course that you'll never do, probably. So test 1 grade, what year, what program you're in, maybe let's give it a, let it look like this. Your test 1 grade is just ever so slightly increasing as you go through your years of school. Right? As you learn more and you learn how to learn, right? It's reasonable to think that your grades might improve. Right? Just a hypothetical. If I had to model this relationship, so look, it looks weird, right? Because all the dots are just stacked on top of each other. but it's not that different from them being on a numerical scale, right? And so I can still model this relationship, right? And I can still predict the test 1 grade from whatever program you're in, but we'll see more of that later. But that's what it looks like if you had a categorical variable on your x-axis. Okay. Way back here. Must have been way earlier. We're often interested in the relationship between two variables, two kind of vaguely named variables. Then we were focusing on two numerical variables, right? And then now I've just briefly introduced a numerical variable and a categorical variable together, right? So maybe I should say that. One numerical variable and one categorical variable. Test 1 and program. Right? Looks something like this. Final stop has to be two categorical variables, right? So what if I have two categorical variables? Let's say program, and for these purposes, how about I treat the year you're in as a categorical variable, right? You can kind of use it however you'd like, and year. We could create age ranges or something like that, but let's just stick to some simple things. Now, there are graphical visualizations that we'll introduce, but I think the easiest way to summarize the relationship between two categorical variables is going to be a two-way table or a contingency table. And so the easiest way to summarize the relationship between two categorical variables is a contingency table, or a two-way table, if you prefer. What's that gonna look like? It's gonna look like this. It's a table where you have variable 1 and you have variable 2. You can swap those. There's no, unlike the x and the y axis on a scatter plot, it doesn't matter which one you put where, as long as you're consistent, I guess. So let's say variable 1 can be your program. And let's say variable 2 can be the year that you're in. let's say wet 1, wet 2. Hopefully they still have 2 streams right there. Yeah. Let's say science, and then just for fun, let's do nursing. The year, first year, second year, third year, fourth year. Let's say we'll cap it there. Those are numbers, right? And we had that kind of decision to make, and we are allowed to treat it as a numerical for some analyses, and we are allowed to treat it as a categorical for other analyses, as long as you kind of keep those straight. In this case, I'm treating it as a categorical variable. Now, here, I'm going to have a number here. What's this number? This number is going to be the number of students in first year and in the first wet program, whatever it is, right? And so this number, that number is the number of students, or maybe I should say the count, but I'll just call it the number. The number of students in wet 1 and year 1. Can keep going, right? We're gonna have a 4x4 table of counts. Okay. But we can also look at the totals. Uh-oh, I'm running out of orange. Let's see if it shows up. Good enough. Or maybe I'll, instead of this number question mark business, maybe I'll letter them A, B. A, sorry. What would B be? Because then I don't need the different colors. Anyways, whatever. B is the total across the row, right? The row total for year 1. So that's going to be all the total number of students in first year, right? The number of students in year 1. I'll keep orange because it's still a total. But what about the total for the first column? It's going to be the total of students for the first wet program. I wish I could. Is it environmental? Remind me. Environmental monitoring and MWT, wastewater. Wait. Whoa. There. There, now I feel better. I'll try to remember those. What one, what two. That works for me too. Okay. So what's C then? That's going to be the total of students in EM, environmental monitoring. The number of students in does this total have to be? Right, this is going to be the total of everyone in first year, second year, third year, fourth year. Let's pretend there are no more years, right? And that should be everyone, right? If there are no more years, then that should be everyone in my sample, right? Making this total my lowercase n again, right? So here, this is my sample size, right? That's my total in my sample. It has to add up for the columns as well, right? If you've broken down into 4 distinct categories and those are all that exist, right, in this class, then if I add up all the students in environmental monitoring, all the and all the science and all the nursing, then that should be my sample size, n, right? And so these totals, and so the column totals and the row totals both add up to the same number, n. Okay. Now we can use these counts to talk about, what proportion of science students are in their third year, for example, but we'll save that for another time. I had some problems that I wanted to work through. Oy, 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 oy. So at the end of the chapter, she summarizes all the terms that you should be familiar with. There's some of these that we haven't talked about, right? Associated, we talked about that, right? 2 variables have an association or there's a relationship there, right? If there's a pattern, right? If you can see some sort of positive or negative relationship, then they're associated. We didn't really use case, but a case is the observation. And let's see here. Talked about categorical a lot. We didn't talk about cohort, but I think you can kind of get there, right? You're in a cohort, you're in the lab program, right? You're a group that moves together. Continuous, talked about continuous variables, right? Data, we talked about data, right? I don't know if I ever called it data, but it's all data. A data frame. Data frame is essentially that spreadsheet that we've been imagining, right? And so dependent, right? We said, okay, if there's an association, then those 2 things are dependent on each other, and so on. And so you can kind of walk yourself through. There are some things that I haven't mentioned, like placebo, but I think just from life, we have an understanding of what placebo is. It's more for experiments, or it is for experiments, right? Which I kind of tend to avoid until a later date anyways. Okay? But a placebo is something that looks like a treatment that you give to your experimental subjects, make them think they're getting the treatment, just so you can have a control group. Yeah? But there's kind of a fun introductory section that she starts with in section 1.1, which introduces an experiment with some pretty wacky results. So you can read that just for fun. But, oh yeah, so the answers to the odd numbered exercises are in the appendix. And so I try to choose even numbered exercises. I'm going to copy this. Maybe I should put it on a freshie. So the data frame contains information on runners and okay. There. In the 2017 Cherry Blossom Run, which is an annual road race that takes place in Washington, D.C., most runners participate in a 10-mile run, while a smaller fraction take part in a 5K run or walk. Taking some issue with the different measurements. 10 miles or 5K. I don't understand it, but they can do whatever they want, I guess. How many observations and how many variables does this data frame have? Right, so, and what are the observations? How would you communicate what they actually are, right? And so the number of observations that you have is this number here, 19,961. So let's see here. Let's go to my trusty pink. My sample size is 19,961 runners. Or I should say participants, I guess. I don't think you have to, but they do say they're runners, doesn't matter. And so you have 19,961 runners. You don't want to be scrolling through all that. What a mess, right? But you've collected some information. You've got the bib number, which is kind of a decoy, right? It is a number, but you're not going to expect anyone to have the same number, maybe an error, right? But because everyone's just assigned a bib number, right? It's not really anything that we're interested in, and I would call it a categorical variable. And so here, even though it is a number, I'm not interested in the average bib number, mostly because I created the bibs and I handed them out, right? And so I'm not going to analyze that. Their name seems reasonable to have, right, as information. Again, I would call this a categorical variable, and I guess it didn't ask us to identify, but it is something I want you to do, so we're doing it. So for each of these variables, right, think about if you would call it a categorical variable or a numerical variable. And so I'll tell you what I think, and you can kind of self-check. But name, I definitely categorical variable, so I can't take the average name. If I could, that'd be kind of cool, I guess. There's a video on kind of the typical person in the world, just taking all the most common demographics and combining them, and it describes the most typical person in the world. So maybe I'll post that video because it's kind of cool, right? They look at all these demographics and it generates this typical person, right? And it's interesting because no one is actually going to be exactly like that typical person, but that's the beauty of stats. Sex, categorical, age. I can be flexible, but maybe if I want to do a scatter plot and I want to keep just the ages, then it's nice to treat it as a numerical variable. And so I'm going to call it a numerical variable. But like I said, it's one of those kind of flexible ones where you could maybe be persuaded to treat it as a categorical variable if you wanted to summarize it in a table, right? But if you wanted to make a beautiful scatter plot, then you would call it numerical. City, country, well, that's categorical, of course, because no way around it. How about their times? I'm assuming that's is it in seconds?
Yeah.
Right? That seems reasonable. And so let's see. So we've got the net time, the clock time, and then the pace. All of those I would call numerical, right? Time is numerical, whether it's net or clock. And so here I would call this all numerical. And then the event that they ran in, there were only two options, right? Could take it one step further and say it's a binary categorical variable, right? 0, 1, but we'll just call it categorical. Okay. So if I give you output like this, I give you a spreadsheet, right? Or an excerpt of a spreadsheet, right? I expect you to be able to identify what type of variable you have, right? The number of observations, and then what else did it asked for? How many variables does this data frame have, right? So that's going to be our last thing. And I would say, so remembering that they've kind of helped us along here because they didn't put a column for the observation because it's not a variable. Okay? But usually my questions will have that decoy of the observation, just to really hammer home that the observation number is not a variable, right? It's just an ID number. And then 1, 2, 3, 4, 5, 6, 7, 8, 9 variables. And we also broke it down whether it's categorical or numerical. Hey, I had more questions I wanted to do. I'll just bring them in and you can look at them and try them over the weekend, and then we can start there. Next week, because I guess I don't see you, which feels kind of weird. Copy. So I think it's just question, oh, I guess I did 12 as well. But that's just practice that we just did, so let's cut that one. So try question 4 and question 8 on your own, and we'll do them for review to start next week. If you have any questions, let me know. Otherwise, enjoy your weekend. We'll see you next time.